Look up at the sky on a clear night, and you are looking at a graveyard. The light reaching your eyes left its source millions, sometimes billions of years ago. And many of those stars no longer exist. They burned, they collapsed, they vanished without witnesses. Tonight, we are those witnesses. Because the universe is dying, and we are fortunate enough to be alive during a brief, extraordinary window when there is still light left to see. Somewhere on the far edge of a galaxy cluster, a star is taking its final breath. Its core, once a roaring nuclear furnace, has exhausted the last of its hydrogen fuel. The outer layers are collapsing inward, then bouncing outward in one final, magnificent shudder. We call it a supernova, but across the vast cold timeline of the cosmos, it is something far simpler. It is an ending. Pull back far enough, and you see that the galaxy surrounding it has already gone dark. Billions of stars, each one a sun, each one perhaps circled by worlds, now cold and silent. This is not a distant hypothetical. This is the destination toward which all things are traveling. The universe has a beginning, and it will have an end. What happens between those 2 points is the most extraordinary story ever told. We arrived late to the story. Humanity took its first breath in the final seconds of a cosmic calendar that stretches across nearly 14 billion years. And yet from the moment we could look upward, we reached. We stacked stones to track the motion of the stars. We built lenses to pull the sky closer. We pressed our ears to the ground and heard the faint hum of creation itself. And then, one October morning in 1957, we finally broke free of the planet that made us and launched a small metal sphere into orbit around the Earth. It beeped. That was enough. The door was open. Humanity's hope, fragile and extraordinary, had been aimed at the stars. But hope alone does not cross interstellar distances. A generation ship, a vessel designed to carry not one crew but many, across centuries of travel, drifts through the void between stars, and the void is almost incomprehensible. Not empty like a room is empty, but empty in a way that dismantles the human sense of scale entirely. The nearest star to our sun is over 4 light-years away. At the speed of our fastest spacecraft, the journey would take 70,000 years. The cosmos does not care about our schedules. Time here is measured not in lifetimes, but in the slow turning of civilizations, the rising and falling of entire species. Think of an hourglass, but instead of sand, imagine that each grain is a star. There are an estimated 2 trillion galaxies in the observable universe, each containing hundreds of billions of suns. Now watch the hourglass drain, slowly at first, then faster. The stars are not eternal. Every one of them is burning through a finite supply of fuel, and when that fuel is gone, the light goes with it. We live inside the hourglass, and the sand is falling. An astronaut floating far from Earth, visor turned toward the infinite dark, knows this in a way that cannot be taught in any classroom. Out there, in the absence of atmosphere and noise and the comforting blue of a sky, the universe reveals its true face, ancient, vast, and indifferent to the creatures it briefly permitted to exist. Scientists have known for decades that the universe is expanding. Galaxies are not simply moving away from one another. They are being carried apart by the stretching of space itself, accelerating as they go, driven by a force we call dark energy that we do not yet understand. The consequence is chilling. There will come a time when every galaxy beyond our own will have receded beyond the cosmic horizon, traveling away from us faster than light can carry their image back. We will be alone in an apparently empty universe, with no way of knowing that anything else ever existed. The cosmic web will be severed, galaxy by galaxy, star by star, until silence is the only answer to any question we ask of the sky. This leads us to a question that has haunted astronomers and philosophers for generations. If the universe is this old, this vast and filled with hundreds of billions of potentially habitable worlds, then where is everyone? Where are the radio signals, the megastructures, the civilizations that should, by any statistical reasoning, have preceded us by millions of years? The silence is total. Some call this the Fermi paradox. Others see it as a warning. Perhaps every intelligent civilization before us collided with some invisible wall, a great filter, some catastrophic threshold that ended them before they could spread across the stars. Perhaps that filter lies behind us, in our evolutionary past. Perhaps it lies ahead. The silence of the sky may be the most important data point in human history, and we do not yet know what it means. There is a darker interpretation. Some theorists propose that the galaxy is not silent because civilizations are rare, but because they are hiding. The universe, in this view, is a dark forest. Every civilization that announces itself becomes a target. The rational strategy is silence, concealment, the careful masking of every electromagnetic signature, every flash of energy that might betray your presence to something older and more capable than yourself. If this is true, then the stars we see are not empty. They are watched. And the civilizations that survived are the ones we will never find. Deep space is hostile to life in ways that go beyond loneliness. Radiation saturates the void between stars, a constant, invisible storm of high-energy particles that would penetrate any ship, any suit, and quietly dismantle the DNA of anyone inside over the course of a long journey. Micrometeoroids, no larger than a grain of sand, but traveling at tens of kilometers per second, can pierce a spacecraft hull with the energy of a small explosion. And then there is the interior threat, the slow psychological unraveling that comes from confinement, from the absence of horizon, from the knowledge that rescue is not coming, and the nearest human voice is a radio delay of months or years. The first astronauts who left Earth knew something of this. You can see it in their faces in the archival footage, a look that is equal parts terror and transcendence, as if they have seen something that the language of their time was not yet equipped to describe. We have already found, closer to home, hints that life does not require our particular conditions. Beneath the frozen crust of Europa, one of Jupiter's moons, a liquid ocean stretches deeper than any sea on Earth, kept warm by the tidal flexing of the moon's core. No sunlight reaches it. No atmosphere surrounds it. And yet the chemistry, the heat, the water, all the ingredients are present. If life has found a foothold there, it will look nothing like us. It may not use light at all. It may process information through pressure waves or chemical gradients in ways we cannot yet imagine. The universe may be full of life that we would not recognize even if we were looking directly at it. If humanity endures long enough to travel to other star systems, to colonize other worlds, to survive the radiation and the distance and the politics of a civilization stretched across light years, we will not remain human in the way we currently understand the word. The body that evolved on the savanna of Africa, shaped for running and climbing and breathing oxygen at 1 atmosphere of pressure, is poorly suited for the cosmos. We will modify ourselves, genetically, cybernetically, radically. We will splice new tolerances into our biology and wire our nervous systems into machines. Eventually, the children of our children's children may drift freely through the vacuum, look back at the fragile biological form their ancestors wore, and find it as alien as we find the fish from which we evolved. Whether what they become is still, in any meaningful sense, human. That is a question that belongs to the future. But even the futures we can imagine have limits. In the very long run, the physics is unforgiving. We are living in what cosmologists call the Stelliferous era, the age of stars. It will last another 100 trillion years, a number so large it mocks every attempt at comprehension. And then the last star will exhaust its fuel. White dwarfs will cool over incomprehensible timescales, dimming from white to yellow to red to black, dead embers drifting through a dark and empty cosmos. Neutron stars will collide, producing brief violent flashes of energy that illuminate nothing, warm nothing, create nothing new. And the black holes, patient, massive, inevitable, will inherit what remains. For a time measured in numbers that require scientific notation to write, 10 to the power of 40 years and beyond, black holes will be the dominant structures in the universe. Everything else will have been swallowed, decayed, or dispersed. And still, they will persist, but not forever. Stephen Hawking showed us, through the elegant mathematics of quantum mechanics applied to curved spacetime, that black holes are not truly permanent. They leak, slowly, imperceptibly, over timescales that dwarf the current age of the universe by factors that exceed comprehension. A black hole radiates away its mass in a faint glow of particles, and eventually, in one final burst of light, vanishes entirely. The last black hole to evaporate will produce the last flash of energy anywhere in the universe. After that, there is nothing. A thin, cold, diffuse gas of photons and electrons spreading apart forever. Temperature descending toward absolute zero and never quite arriving. Entropy complete. The universe at rest. This is the heat death. Not an explosion, not a collision, not a dramatic finale, but a whisper. The final state of maximum entropy, where no energy gradient remains, no work can be done, no thought can be completed. If there is a mind still operating in that era, some digital consciousness running on the rotational energy of the last black hole, sustaining itself on the faintest trickle of available power, it will face a horizon beyond which there is simply nothing left to compute. The last thought of the last mind, extinguished not by violence, but by the quiet running out of everything. And yet, physics suggests that in a universe of perfect stillness, quantum fluctuations do not stop. The vacuum is never truly empty. Random sparks of energy flicker in and out of existence, governed by probabilities so small they border on the impossible. But in infinite time, even the impossible eventually occurs. A new universe could, in principle, bootstrap itself into existence from a quantum fluctuation in the dead remnant of the old one. The Big Bounce, some theorists call it. The possibility that our universe is not unique, but is one chapter in an infinite series, each cosmos collapsing or evaporating, each giving rise eventually to the next. The Big Bang that created everything we know may not have been a beginning at all, but a transition. One beat in a rhythm too slow and vast for any single universe to perceive. If this is true, then somewhere in the foam of possible realities, other universes are being born right now, each with its own values for the fundamental constants, some too hot, some too cold, some collapsing before a single atom forms, some expanding so fast that gravity never gets the chance to pull matter together into stars. We won the cosmic lottery. We exist in the narrow window of physics where hydrogen ignites, where carbon bonds, where water flows liquid, where consciousness becomes possible. Look up again. The stars you see are not just beautiful. They are historical documents. The light leaving a star 100 light years away carries an image of that star as it existed 100 years ago. A star 1 million light years away shows us what it looked like a million years before the first human being stood upright. We are not looking at the sky as it is. We are looking at the sky as it was, a vast, layered record of the past, and we are surrounded by it on every side. Many of the stars we see are already dead. Their light is still traveling toward us, carrying news of their existence to a future that outlived them. We sent our own message once. The Voyager probes, launched in 1977, carry golden records, discs encoded with sounds and images of Earth, greetings in 55 languages, the music of Bach and Beethoven and Chuck Berry, the sound of wind and surf and a child's laughter, mathematical diagrams and the location of our sun relative to the pulsars of the galaxy. It was not a scientific instrument, it was a letter, an act of faith that somewhere, across distances we cannot cross, something else exists that might one day find it, decode it, and understand that once, in this corner of the Milky Way, there was something that thought and felt and wanted to be known. Even if no one ever finds that record, even if our civilization ends tomorrow, consumed by its own conflicts, by the asteroid it failed to detect, by the resource it failed to share, even then, the Voyager probes will continue their journey, past the heliopause, out of the solar system, into the cold between stars, drifting for billions of years through the galaxy, carrying Bach and laughter into a silence that may never end, or may someday be broken by ears we cannot imagine. We are Stardust. Every atom of carbon in your body was forged inside a star that lived and died before our sun was born. Every iron atom in your blood was scattered by a supernova explosion billions of years ago and drifted for millions of years through the interstellar medium before gravity and chemistry assembled it into you. The universe is not separate from us. We are what the universe looks like when it has had 14 billion years to become curious about itself. We will not last forever. The sun will swell into a red giant in approximately 5 billion years and consume the inner planets. Long before that, we will need to have become something capable of surviving beyond this single fragile world. We have everything we need: the intelligence, the tools, the knowledge, the imagination. What we have struggled to find is the will, the political courage to look past the next election cycle, the next quarterly report, the next border dispute, and see the longer arc of what we are and what we could become. The universe is not waiting. It does not care whether we make it or not. It will continue its slow, magnificent, indifferent expansion long after the last trace of human civilization has been dissolved by entropy. But right now, in this brief, improbable, luminous moment, we are here. We are conscious. We are capable of understanding the scale of what surrounds us, and finding it beautiful, and asking what it means, and trying to answer. That is not nothing. In a cosmos 13.8 billion years old, full of dead rocks and collapsing stars and empty space beyond measurement, a creature that wonders is an extraordinary thing. Perhaps the most extraordinary thing there is. The Milky Way stretches overhead, 200 billion stars, each one a sun, most of them orbited by worlds we have never seen. We are a pale blue point of light at the edge of one of its spiral arms, young and temporary and astonishing. And we are, for this moment, alive.